Hi, everybody. Thanks for joining us. We've got a few more minutes before we'll kick things off, but I just wanted to go ahead and jump on and welcome everybody. I see we're getting a few more joining. We'll begin in just about 2 minutes. Thanks. Good morning. Welcome. Happy Friday to you all. My name is Joe Kozlowitz. I'm on the marketing team here at Lunavi. I just want to thank everyone for jumping on today to learn about Azure architecture. Before we start, just a heads up that we are recording this session. If we go long or if you need to drop early, you will receive a recording link via email. Because you signed up for the full series when you registered, on the week of each session, you will also receive join reminders, calendar invites, and recordings for each of them. You do not have to join us for every session, but we'd love to see you. If you have questions at any time, please feel free to go ahead and drop them in the chat. It is private, so only I, myself, and our presenters will see them. We have a lot of participants today, so please, when you're asking questions, try and keep things on track. We'll only pause for the most pertinent questions. Remember, everyone else is here to learn as well, so let's try not to get too bogged down in specific use cases. We will have time at the end for Q&A, and you can always reach out to Aman or myself if you have questions after the session. I'll also be posting a couple of polls, so keep an eye out to vote. Really quick background on Lunavi before I hand things off to our presenters. We offer what I like to call data center to DevOps. We are a true end-to-end provider for the services and processes that run your business technology. That means everything from colocation and data center modernization, your typical managed IT operations, all the way up through cloud solutions and custom application development and DevOps. We are one of just a few Azure expert MSPs in the world, and we work exclusively in Azure as our hyperscale cloud platform of choice. So please keep us in mind if you have any upcoming projects. Our session leaders are Aman Sharma and Eric Bogensheutz. Each of them have deep experience working with Azure and Microsoft platforms to deliver enterprise-grade IT solutions. Aman is a multi-year Microsoft MVP and a principal architect here at Lunavi. Eric is lead Azure architect at our client Eversource Energy. Eversource is a member of the Fortune 500 and the largest energy provider in New England, serving over 3.6 million customers. As you might imagine, a company of this scale has a complex mix of technology helping to literally keep the lights on. This slide represents some of the ways Lunavi and Eversource have worked together over the years. The blue boxes highlight services and solutions that we have delivered. As Eversource continues its journey towards advanced metering infrastructure, data and analytics, I know, will be a major focus alongside increasingly advanced cloud solutions and agile methodologies. So I'll go ahead and get out of the way now and let Aman and Eric do their thing. Thank you for listening.
Sounds good. Thanks, Joe. I'm going to go ahead and take over the screen share and just put in the chat, somebody, if you don't mind, make sure that you can see, or Aman, if you want to let me know.
Yes, I can see now, Eric.
Sounds good. Thank you. All right. Just give me one moment, just getting set up here. Okay, in today's session, we're going to talk about Azure architecture. We're going to discuss and review the following. We're going to start with an introduction of why architecture matters, follow with design principles, and then go into an overview of Azure's well-architected framework, discuss Azure Advisor, and lastly, we're going to review commonly used standard design patterns and finish off with an opportunity for questions. So what is cloud architecture? Architecture at a high level is all the components, subcomponents, and required cloud solutions that typically make up any deployment. The components are typically something like a front end, back end, delivery method, and a network to deliver it to. A well-architected solution can help reduce cost of maintenance, supportability, help drive modernization, and ultimately help drive a business forward. A couple of things that are very important to consider in any solution is total cost of ownership and the security of the architecture that you're deploying. So that brings us to our next section, which is going to be the Azure Architecture Center. If you've never visited it before, it's a really great spot, kind of a one-stop shop for all reference architecture, important design principles to consider, commonly used design patterns, and various links to other Microsoft documentation and how-tos. If we take a look at the Architecture Center, we can see here at the top that we can browse different architectures. We can look at common cloud best practices. We can view how-to guides on access, optimization, and reviewing workloads. And they have a great section here for what's new in Azure. If we design at the bottom, then we can also see designing for cloud. And our next section, which Aman is going to go over, I'll hand it over in just a moment, is going to be well architected and design patterns. So if we jump into cloud best practices, we can see the Architecture Center on the left-hand side is laid out in a tree view. At the top, we'll see fundamentals, design patterns. One of the good sections here that I typically like to go into is the industry solution within Azure. So if we open up our industry, energy, for example, we can see here that Azure has a good way, and not just in our industry, but all industries, of commonly used items that people may have used before you to help you kind of drive your technology forward in your area, in your industry. Another area that I think is very beneficial is under the technology choices here. So anytime that you're going to choose a technology, you have to start with a base set of questions or base problem that you're trying to solve. If we just open up storage, for example, one of the areas, and they have that for all the main common areas within Azure, is different options, and then key questions that you might ask your business when you're helping to design or architect a solution. So key questions, for example, will you need to provide a location for backup? Based on those questions, you can go down and you can see common scenarios too. So things like, I have an enterprise SAN or all flash array. They help you have suggested solutions and also considerations with any of those solutions. From here, we're going to go over to design principles, and I'm going to hand it over to Aman to talk about the next section.
Thanks, Eric. So I'll take over the screen sharing. All right, let's talk about design principles. I see from the poll that we have quite a few experienced folks joining us today and some who are new to the cloud. So the design principles, these are the key fundamentals. I know we are going to talk a lot about theory in today's session, but this is the foundation. This is the foundation on which the whole building of your cloud journey is going to set up. If you are experienced in cloud, these are going to strengthen your foundation. And within the foundation itself, these design principles, they are like pillars. This is on which everything else is built. Let's walk through what the design principles are. Basically, Microsoft lays out that there are 10 essential design principles. All the well-architected framework that Microsoft prescribes or the design patterns, everything adheres to one or more of these design principles. These are like the foundation of the foundation. Let's look at what these design principles are. Number one, design. Design for self-healing. Your application should be able to recover from a failure. What this means is you should always expect failures happening in the scenario, in your solution, whatever you're building. For example, if you're deploying a web app, if you're deploying the web app in, let's say, two regions, in the eastern region and the west region, imagine what happens if the east region goes down. Your application should be redundant enough, deployed in a highly available scenario that if one region goes down, the other will be processing the requests. You have never seen Microsoft.com go down, even though the data centers behind the scene, they're always taking the outages because of designing for the self-healing. The next design principle is making all things redundant. Try to build redundancy into your application to avoid having single points of failure. Always try to identify what is the single point of failure in your architecture and then ensure that that is redundant. This ties into the first design principle as well, that is designing for self-healing. If the things are redundant, if one item goes down, the redundancy ensures that the other components of your solution will be able to self-heal. The third design principle is minimizing coordination. Now this ties directly into scalability. If you minimize coordination, for example, between the UI component and the business layer, between the business layer and the database layer, that means you will be able to scale up or scale out as you require without having effect on the other parts of the application. Let's say the customers are, or the end users are reporting that they are able to access the GUI fine, but the database, the query response is very slow. So you want to scale out or scale up the database layer. You can do that if you minimize the coordination. And this ties directly into the fourth design principle, that is always designed to scale out. Scaling out means scaling horizontally, which means adding more servers. Scaling up means adding more power to the existing server. For example, scaling up means you have a 32 GB memory server. You will upgrade that to 64 GB memory server. Scaling out means adding one more server and deploying your application to that second server, which is also of 32 GB or less memory. You always try to design your application that you have the scalability inbuilt into the application architecture. If you deploy your application in multiple instances, it is able to retain the state in some mechanism. It is able to process all the requests without losing on the scalability aspects. Fifth design principle is always partition around limits. In Azure and in every cloud, the cloud provider puts some service limits. You can find out what the service limits are for the resource type that you are going to leverage, depending upon the cloud provider, directly from the cloud provider. For example, for Azure, there is completely documented way from where you can find out how much storage account, how many storage accounts you can build in your subscription, and what each storage account's size can grow up to. Similarly, for database, you can find out what is the maximum size of the database that can be there. You should partition your database in a way that you never come close to these service limits that are there in the cloud. Sixth design principle is you always design for keeping operations in mind. What this means is when you are developing your application, when you are creating the design for your application, you should always consider monitoring, you should always consider deployment and other aspects of operation directly built into your design. This will help you achieve more agility when you will be building and deploying your applications. When possible, you should always try to leverage managed services. This means that you always want to pick PaaS services, that is platform as a service, over building the service by yourself based on infra, that is infrastructure as a service. A good example would be you should try to leverage Azure SQL database instead of a managed instance of SQL or SQL server deployed on a VM. This helps in the longer run by reducing the cost in terms of supportability, in terms of management of that SQL instance. Next design principle is use the best data store for the job. Today, there are so many different kinds of data stores. There is data lake, there is Azure storage in general, there is Cosmos DB, Cassandra, MySQL, SQL database. So many options you have for storing your data within cloud. This design principle talks about that you should evaluate each and every data store while designing the solution to ensure that you have selected the best data store for the job. The ninth design principle talks about designing for evolution. Always consider agility in your solution. Don't try to configure your solution or design your solution in such a way that it becomes monolithic over time. The technology in today's world, it changes every 6 months. What is relevant today may or may not be relevant down the line. So you should always consider evolution when designing your solution. One aspect is you should consider minimizing coordination. If you have created different services and they are not tightly coupled with each other, that means each and every service can change as long as the interface through which it is interacting with other applications that remains the same. You will be able to leverage the latest and the greatest technology that Microsoft Azure has to offer if you design your applications for evolution. The last design principle is you should always build for the for the needs of business. Any design decision that you make must be justified by a business requirement. You should not just build the design because a particular new feature just came out in Azure. Although the feature sounds very appealing, if it doesn't justify your business requirement, that means that you don't need that. You don't need the overhead of managing that service. You don't need the overhead that the cost for that service brings to your solution. So every decision that you take during the design should be justified by the business requirement. These 10 design principles together formulates the foundation on which the upcoming sections will be laid out. And the next section will be talking about is well-architected framework. And for that, Eric, I hand it over back to you.
Sounds good. Thank you. So well-architected framework. What is this? Well, this is not a, excuse me, not a universal, or excuse me, is a universal concept. This is something that actually every cloud provider has a set of their own um, guidance and own pillars. But within Azure, what it means is it's a specific 5-pillar workload level based guidance. And the goal of all of these is to improve the quality of any workload. Now, it's not all inclusive, so this is never going to include everything that you may see, but it is a good set of universal concepts that you should consider anytime that you're deploying, managing, or doing anything within any cloud. Again, keep in mind that irregardless whether you're using Azure or AWS or GCP, they all have their own. So it's always good to review those to make sure that it's relevant to what you are deploying. So what are the key pillars? First key pillar is cost optimization. Managing costs to maximize value is really what this is about. You want to minimize waste, you want to spend money where you can and make the greatest use out of it. The next key pillar is operational excellence, so OpEx. Operational excellence is really the operation process that keeps any system running in production, so DevOps pipelines, etc. Next one, performance efficiency. So this is the ability for a system to adapt to any change. Aman had talked about this before. You should always be able to adapt to anything going down, and your application should always remain up. So that's the ability for resource capacity scaling, dynamic application scaling, the ability to take an outage and still have your application be up, etc. Reliability then comes into play next, and that's the ability to recover from those failures. So when the failure occurs, you should be able to have your system automatically recover, adapt, anticipate failures if possible, and recover within any RPO, RTO, or any agreed timeline that your business may have. The last one is security. So when you're looking at security, you always plan for security, and you need to protect applications from data level threats along with infrastructure level threats. And then in the app world, you also need to protect against app level threats. So it's really all three of those together to be able to protect against the whole design and the whole architecture together. So looking further into these, we have the cost optimization again. Looking at cost optimization, we're going to provision with optimizations in mind. Anytime we can, we're going to use PaaS instead of IaaS. Anytime that we can, we're also going to reserve instances or apply any reservations that we can to reduce the cost of that spend. We're going to monitor the spend actively. That can be done through Azure itself. That can be done through a third-party tool, but Azure does make it pretty simple with built-in options. Any areas for improvement, always bring that back to your business and recommend those, and always reduce extra man hours by factoring in how you're going to support and maintain your application and any infrastructure that you deploy. Operational excellence, or OpEx, we need to ensure that we have the fastest delivery method possible. So agility with DevOps and CI/CD pipelines, have better monitoring in place, leverage automation whenever possible, and do integrated testing at the time of deployment. When we're looking at performance efficiency, we're looking at the ability to meet demand dynamically. So that could be scaling up, scaling down, scaling in, scaling out. The other side of that too is what load that puts on your network. So you should always plan that into your architecture, making sure that you have the correct bandwidth selected, the right SKUs selected, the right performance of storage selected. And if there is any identified bottlenecks, make sure you identify those, call them out, and document them within your solution. Reliability, again, the ability to handle any failure with minimal impact. So your RPO and your RTO, you need to make sure that any solution that you're deploying, you have those defined and well documented so that everybody is on the same page when it comes to how fast you're going to recover and the amount of data loss that you can endure to still keep your solution at the business need that you have. So anytime that that happens, you have to factor in also disaster recovery. So what that means for your solution, if that's something like Azure Site Recovery, or if you're going to do something where you have a solution always on and highly available. The next slide we're going to talk about is security. I'm going to pass this back over to Aman to talk about that.
So when it comes to security, which is one of the most important pillar of well-architected framework, there are different layers that the security can be applied to. And we'll look at each and every layer which are depicted on the right side of this slide. Security means defending your application, defending your whole design, your solution in every layer that is being depicted here. Different security controls, different technologies and capabilities will apply to each and every layer. So for example, let's start with the data layer at the bottom. When you talk about data layer, that means encryption at rest and encryption in motion of the data. In Azure, that is inbuilt into the system. When you talk about encryption at rest, encryption in motion is what you are responsible for. When you build your applications, make sure that you leverage HTTPS instead of simple HTTP. That ensures that the data is encrypted whenever it is flowing from one area into the other. That is from the data store, from your SQL database, for example, to the GUI from where the data is displayed. The app layer or the application is how the end users interact with your data. This is the place where SQL injection and the cross-site scripting can occur. So make sure you always think about those items and have the security inbuilt into your applications. On top of this comes the VM and compute layer. At VM and compute layer, a malware could be installed on the VM, or credential exposure and lateral movement through the environment can occur. To limit this, always ensure that the VMs or the compute area of your application that is always protected and is always monitored from time to time. Above that is the networking layer. Unnecessary open ports at this layer to the internet is one of the biggest cause of security lapses. SSH or RDP should be locked down and should be open only when required in this particular layer. If a brute force attack occurs, that occurs at this particular networking layer. On top of the networking layer is your perimeter. Perimeter layer is how anyone will come and connect to your environment. This is the layer where DDoS attacks can occur, that is denial of service attacks. And in fact, just a quick tidbit, yesterday Microsoft prevented a 3 terabyte plus DDoS attack that somebody was trying to execute on Azure environment. And that was one of the biggest news in security forums yesterday. So these attacks can overwhelm your network resources. These can force them to go offline and making them incapable of responding to legitimate requests. Above the perimeter layer is policies and access layer. This is the layer where authentication occurs. Modern authentication protocols here like OpenID Connect, OpenID Connect, OAuth, or Kerberos-based authentication such as Active Directory, those all exist here. When I talk about policies and access layer, think about conditional access that is available in Azure AD that you can leverage here to restrict the access. Exposure of credentials is a big risk at this particular layer. Limiting the permissions of different identities is something that you can take care at this particular layer. Monitoring in place also need to be put in to look for any possible compromised accounts. For example, somebody logged in from, let's say, Stanford location, and in a short while, they are logging in from, let's say, California location. Within an hour, nobody can reach from Stanford or US East side to the US West side within an hour. That means either the person is legitimately accessing the application using a VPN, they're trying to simulate an attack, or somebody is trying to attack your system and trying to do something nefarious. In that scenario, the conditional access policies, they can take care of this. If such anomalous logins that occur, the policies will ensure that those are blocked and the access is limited for those other entities. Finally, the outermost layer is physical security. This is where access to the excuse me, access to the facility is taken care of. prevent tailgating, for example, the theft of security badges, for example, that all comes into this layer. When we are designing solution, this is the layer we are least interested in, but somebody in your organization, they will be taking care of this. Now, from all of this aspects of the security, people and process, that is another aspect that we need to take care of. For example, the ransomware attacks and various other types of attack, they are mostly social in nature, in that they try to target people and the process rather than the technology itself. So we need to ensure that people and process, they are taken care of, and they are educated, for example, and they are aware what all processes they need to follow and what to avoid, what to watch out for. It is a shared responsibility. It's not just the responsibility of the person designing the solution. It is, security is a shared responsibility of everyone, of the end users, of the people involved in deploying the application, and people involved in developing and designing the solution. And that brings us to the responsibility segregation. So here in this slide, it shows which component are are the components for which Microsoft is responsible for, which are shown by this light blue color. Which ones are the shared responsibility, which are denoted by this double colored boxes, and the dark colored boxes are the one which are customer responsible. And this slide also tells you why leveraging software as a service or platform as a service over infrastructure as a service or on premises is important. You see, the more abstraction you have from the underlying deployment, the least responsibility it is yours to manage the security for that particular component. Information and data, devices, accounts, and identities, these are always a customer's responsibilities. Identity and directory infrastructure is a shared responsibility when it comes to SaaS or PaaS services, but customer's responsibility when it comes to IaaS and on-prem deployments. Applications themselves, in a SaaS scenario, it is always Microsoft's responsibility. For a PaaS deployment, for example, a SQL database, it is a combined responsibility. How you architect the SQL database, what queries you write, what stored procedures you write, you control those. You always need to ensure that there is no vulnerability for SQL injection in there. Similarly, network controls, similar scenario, operating system for SaaS and PaaS, Microsoft, IaaS on-prem customer responsibility. Physical infrastructure, including host, network, data center, for all of these three, when you are deploying in cloud, this is always cloud provider's responsibility. That is Microsoft's responsibility. Now, why don't we always design an ideal environment? Why don't we always design most secure, highly performance, highly available, highly scalable, recoverable, and efficient environment? All the pillars we talked about, why don't we always go with the best design solution? The answer to that is that there is a downside, and downside in terms of cost. When we say cost, cost is not just related to money. It is also related to time to deliver and operational agility. Sometimes you sacrifice on some aspect to get the operational agility. You want to be agile enough that you go through different iterations and be able to deliver faster. You have less time to delivery, while also not building a solution that is obscenely expensive for including the components that are not even required. Now we'll see all this in action, all the controls we saw in action, and Eric will walk you through the Azure Advisor and the Advisor Score. I send it back to you, Eric.
Sounds good. Thank you. All right. So Azure Advisor, I'm sure a lot of you have heard about this and what it is, but today we're going to go over it along with a real quick demo and just talk about what it does and what it can provide you. So Azure Advisor is a free Microsoft service, and it provides recommendations based on your deployed configurations and services that you've leveraged within Azure. By leveraging Azure Advisor and using the recommendations, it's a great way to refine your Azure services, and it goes directly back to the key pillars that we talked about before. The Azure Advisor and Advisor Score covers cost, security, reliability, operational excellence, and performance. Within that, within cost, you're going to see some recommendations such as, you're going to see recommendations such as reserved capacity, reserved instances, right sizing and shutting down VMs. Within security, you're going to see some information such as how to shut down, how to lock down, etc. Within security, also going back to what Aman had talked about before, you're going to see some items such as making sure that your app services only have HTTPS enabled. Reliability, some of the recommendations that you may have are things such as upgrading standard disk to premium disk, upgrading unmanaged to managed disk, express route and global reach, accessing second regions such as Cosmos DB being replicated. Operational excellence, you're going to see some recommendations such as Azure Advisor or Azure Monitor to your virtual machines, enforcing auditing on VMs, uptime and SLA recommendations. And then lastly, with performance, you're going to see some recommendations around items such as database and storage account tiers to increase performance, to increase and reduce the load. You're going to see recommendations around DNS and time to live. And overall, again, this is a great way to go to get high quality recommendations, but you need to keep in mind that these are just recommendations. There are cases that the recommendations don't always make sense. Going back to what Aman said, you could fix every single one of these and you could drive your cost threefold of what you really need it to be. So you always have to take anything Microsoft recommends as a starting point, not as a definite have to do. I'm going to go into a quick demo and show you Azure Advisor. So by going into Azure Advisor, you're going to see again the 5 key pillars here: cost, security, reliability, operational excellence, and performance. Here you're going to see Azure Advisor and Advisor Secure Score. We'll go into that in a moment. And within any single one of these, you can dive in to see the individual recommendations that it may have. So from cost, you can see that, again, if we click in here, we're going to see recommendations. On the biggest one is buying virtual machine reservations to save over the pay-as-you-go cost. If you were to click into here, you could see all the impacted resources and all the recommendations that it has, along with sizes that it has, the recommended quantity that it has for you to buy, and the term in which that it's calculating that off of. Same thing here. This is a recommendation for a reservation, but this is on a PaaS database instead of on IaaS virtual machines. Same here. You can see a lot of these costs are directly related to reservations. Down here, then, you can also see that it's recommending for cost to use standard storage. So it does go the opposite way too. Not always upgrade, but it is also going down. Security, back to kind of what we had talked about before. Microsoft always pushes the Microsoft products, so that's something to keep in mind as well, which is why a lot of the security recommendations you're going to see have to do with Microsoft Defender for Cloud. So in this recommendation, you can see that it's recommending that Microsoft Defender should be enabled. Same thing here for DNS. And you can see some of the other ones that you have here too. It takes into consideration general best practice within cloud, such as how many subscription owners you should have. Reliability, back to how reliable your application is, how it's handled for outages, anything that you can do to keep that application up more. So if we take a look at some of the ones that are in here, we can see that there's ones such as additional protection to mitigate for that big security vulnerability that came out. There's a recommendation here to protect against that. We can see here that it's recommending to upgrade from premium unmanaged to managed disk. And then also, if we scroll down, we can see that one of the recommendations would be for reliability of high availability of adding a second region to protect workloads such as Cosmos. Operational excellence. Not too much in here. This is, less than some of the other categories that we saw, but we do still have recommendations. So again, using uptime SLAs, financially backed higher SLAs, audit and enforce virtual machines that do not use managed disk. This is recommending to put in an Azure policy for us to help enforce it. And then to performance, the last one, some of those recommendations that we talked about, things like configuring the DNS time to live. We have updating statistics on a table, creating statistics on a table. So this is all directly related to database or Azure database performance. Now, if you were to go into any of these, the other thing you can do here, you can see some of them have things such as quick fix. Same thing under cost, you should see that as well, quick fix. They do have ways right from Azure Advisor to take action on these items as well. So you can go into something like that and you could click on these and you can fix it right on the fly. So Microsoft does build that in with workflow-based fix. And some of them, such as, if we went back to the cost again, some of them, such as buying virtual machine reservations, is not a quick fix. But if you were to go into here, it does still give you an opportunity to add them to your cart and to fix them. From here, we're going to go into design patterns. I'm going to turn that back over to you, Aman, where you can start to talk about the common design patterns.
Thanks, Eric. Before I start with the design patterns, I just want to remind everyone, if you have any questions, feel free to post those in the chat, and we'll take those up as soon as we can. Let's talk about design patterns. If you come from the development world, you know what these are. You know the design patterns, they found the base, and you adhere to one or the other design patterns. There is an acronym in the dev world that is SOLID, which stands for different design principles. And then based on those, you have multiple design patterns. Similarly, for Azure Cloud or any cloud in general, we need some design patterns. These patterns indicate how a particular solution should be built, and generally each and every design pattern is based on one or the other technology usage. There will be one for Key Vault, another for storage account, for example. The way these technologies are architected behind the scene, the design pattern are built around the technology architecture. We'll first look at the design patterns, and then we'll look at some of the most common design patterns. So what exactly are the design patterns? These are general, reusable solution to a commonly occurring problem. So a problem that was faced by not just one person, but multiple end users, multiple customers. Why not build a design pattern to address that particular problem, so that if, let's say, you are going to design a solution for a new customer, if somebody else has already faced it, you can leverage a design pattern and build your solution that way. And the chances are, if you are facing a problem today, somebody else might have faced it already. Another point is the template and blueprint for how to solve and avoid cloud problems is what design patterns are all about. They provide you with a set template, the way you can architect your solution so that you don't need to think about it, where you want the secrets to be stored, how you want the secrets to be accessed, for example. All that will be taken care if you adhere to a particular design pattern within the prescribed all the design patterns. These are the best practices that stood the test of time. So why not leverage the best practices right away? These are relevant to any distributed system, not just Microsoft. Every other cloud provider has a documentation around these, but why not leverage this and have the right foundation before we start architecting the solution? Key parts of a pattern. When you will look at any design pattern within Azure Architecture Center, you will see that these key parts, they apply to each and every design pattern. The first one being context and problem that that particular design pattern is trying to solve. You want to understand what is the context, what this design pattern is going to do. And then comes the solution. How to solve that particular problem is what the solution section is all about. And we'll take a look at that, all of these sections in a short while. Issues and considerations when you implement that particular solution. Even in Azure Advisor, you saw that what are the considerations if you follow a particular recommendation that Microsoft is providing. You need to always be aware of the considerations or the issues related to that particular item. There is no such thing as a perfect solution. Every solution will come with its own baggage, and we need to understand what that baggage is for a particular pattern when we are trying to consider that for implementation or consideration for inclusion in our design. What are the common scenarios when to leverage that particular pattern is covered under when to use that pattern, followed by the examples of that pattern in a real life scenario within Microsoft Azure. And lastly, related guidance. Related guidance would be another design patterns that are applicable to this particular design pattern that you are taking a look at. So remember these key parts. When we look at some of the design patterns, we'll go through these parts within the architecture center. What are the different pattern categories? So when you will look at the catalog of all the design patterns within the architecture center, you will see that all the patterns are categorized into these categories. Primary ones are data management, design and implementation, messaging, and then additional which follow the 5 pillars of the well-architected framework that Eric walked us through. Data management is all about managing your data, how the data should be stored, how it should be accessed. Design and implementation are general design related and implementation related patterns. Messaging is all about storing your messages in a queue and sending the data from one aspect of the application or one component of the application to another component of the application. Before we jump into the most used application and infrastructure design patterns, let me switch to the architecture center. So here I'm back on the architecture center that Eric demoed earlier in the session. Let me show you where all the design patterns are located. On the left-hand side, designing for the cloud, directly from here, you can click on application design patterns, and that will take you to this particular section where all the design patterns are located. So Eric already showed you this particular tree view on the left-hand side, including the top link, which takes you back to Azure Architecture Center. On the left-hand side is the tree view where all the design patterns are located. These are the categories that we were talking about, essentially the challenges that the design patterns are trying to solve. Data management, design and implementation, and then messaging, the distributed messaging system that you leverage within the cloud. At the bottom of the overview page is the catalog of all the patterns. There are around, I believe, 39 design patterns that are located here. And on the right hand side, you see a category of the design pattern. So this is a good place to start. Whenever you are designing a particular service and you see that you hit a roadblock, there are two ways to design the same service. That's the point when you come here to this particular section of Azure Architecture Center and try to search for keywords. That's what I do. And then try to see if there is a pattern already available. The summary helps to decide which design patterns I should look for. If you keep scrolling, you will see all the design patterns here. And let's look at one of the design pattern from this particular section. Let's look at the last one, the valet key. We saw that each and every design pattern is clubbed into different sections. Each and every design pattern has key components. On the right-hand side, you can jump into those sections, which is context and problem, what this design pattern is trying to solve, what is the solution for that particular problem, issues and considerations, when to use this pattern, If it has related guidance, then that will be here as well. So it will give you a summary of the problem this pattern is going to solve, the solution along with an image of that particular solution. We'll talk about this particular design pattern in a short while when we'll discuss most used application and infrastructure design patterns. There are issues and considerations that are related to this particular design pattern. You can see there are not one, but multiple issues and considerations that you should review before ensuring that you implement this design pattern. And then some of the considerations can either be mitigated through your application design or through leveraging some other design pattern. The next section is when to use this pattern. It gives you situations or scenarios when this design pattern is effective or useful to you. And then finally followed by the practical examples where the design patterns can be leveraged, and even code snippets. Let's jump back to the slides and we'll talk about most used application and infrastructure design patterns. Now, this is the pattern we were looking at. The pattern name is Wale key. Just like your car comes with a primary key and a Wale key. The Wale key, usually you keep it at home for emergencies. You don't use the Wale key, you use the primary key. The Wale key is limited in a sense that you can't do all the activities that you can with the primary key. For example, you can't use the Wale key to unlock the car without inserting the key directly into the car. So now this Wale key becomes a token. In software world, in a cloud provider world, a perfect example would be storage SaaS tokens. A storage account has a primary key and a secondary key, which are the keys to the kingdom for a storage account. They never expire unless until you rotate the keys. The SaaS token, through that, you can limit the type of access and what elements can be accessed. Not only that, you can also limit the period for which the SaaS token will be applicable. This SaaS token is the Wale key. It provides a restricted access to the services. If you have any questions related to this pattern, this is fairly simple and straightforward. Instead of leveraging the primary key, use a SaaS token, for example, in case of storage account. In case of any other items as well, instead of giving access to the end user directly to the resources, use an indirect token and then give that access to the end user. That way you ensure that the access is restricted. That way you ensure that the access is time limited. If you have any doubts, feel free to post those in the comment section. By the way, this is going to be our last section for today's presentation. Another good pattern is throttling. Just like you can throttle the limit of water flowing through a faucet by using a knob on the this contraption, similarly, you can control the consumption of resources by putting some throttling limits. You can allow application to use resources only up to a limit and then throttle them when this limit is reached. Couple of examples of this could be, now Microsoft has a limit for number of VMs that can be deployed through CPU core limitation. Number of CPU cores are limited on a subscription. This is a soft limit. You can always raise this limit, but what item up to which you want to raise this limit to? You want to raise this limit to based on your cost, based on your budget that you have. After that, you can still raise the limit, but you control that. You control the cost aspect of your subscription. In terms of resources, API management is another good example. With API management limits, you control how many API calls are made to your solution, to your application. You can create different plans, and based on the plan that which end user subscribe to, you can control how many APIs they can access to. To discuss the next pattern, I request Eric to walk us through the retry pattern.
Sounds good. Thanks, Aman.
Sure thing. Um,
So the next commonly used pattern is the retry pattern. What is the retry pattern? Well, retry pattern would be something where you have an application and you need to allow that application to retry on its own when an exception happens. So an example of this would be handle failures by doing a cancel, a retry, and retry after delay. Some examples of things where you could see this type of pattern used is, for example, server build host step automation. For example, if you're going to install an application on a server after you deploy it into Azure, you might implement the retry pattern in that model where you install a piece of software. If it fails, you wait a period of time and try it again. Or maybe you have an application that has to have a restart before it can be installed. That would be another example of the retry where you're waiting and you're retrying after that restart has occurred. So there's multiple different ways to handle those failures. There's either a cancel, you could retry and you could cancel it. If it fails, you could handle it by retrying again, or you could handle it by retry after a certain period of time. Now, on the flip side of that, there's the next common pattern, which is the circuit breaker pattern. Essentially, the circuit breaker pattern prevents an app from retrying to execute an operation that's likely to fail. So if we take a look at how that differs from the restart or the retry pattern, in the retry pattern, we're purposely retrying after failure. On the circuit breaker type model, we want to, and it's often used together with the retry model, but we want to make sure that if a failure happens and we can tell by some sort of either monitoring or some sort of code that's retrieved from that retry, if it's likely to happen again, we want to stop that from happening so we're not wasting time or wasting retries on something that's likely to fail again. So an example of this would be, say you're doing a server build deployment again. After you do that server build deployment, you want to have it join the domain. If you run the code to join the domain and it can't contact the domain, based on that error code that you get back, you may implement the circuit breaker pattern where you just stop that from retrying and open a ticket with your service desk to then go and remediate why it can't contact the domain. Maybe there's a DNS issue, maybe there's something where it can't contact the network for some reason, or some firewall or NSG that's in the way. That would be a good example of how you're using the circuit breaker pattern. The next commonly used pattern is called gatekeeper. Gatekeeper basically is insert a broker between the client and the service itself. So gatekeeper is often a security-based pattern, but it validates, sanitizes the request, and it adds an additional layer of security in between where you are and where you're trying to go, or where somebody's trying to get to you. So some common resources that you could think about this type of pattern to be used for, or type of resources that would meet this pattern, are things like a application gateway WAF, or the Azure firewall or front door. You can also look at this with patterns of, um, you could look at it with IAM too, with things like conditional access policies. So there's a bunch of different ways to look at this model. It doesn't just have to be infrastructure, but it also could be access control and IAM. So with that said, we're going to move on to kind of what you guys can do next. My recommendation would be, if you're feeling confident with some of the topics that we talked about today, would be to go to the Microsoft Learn page. There is tremendous information on the Learn page that you guys can continue to develop and to grow from. There's fundamental type certifications that you could take next as well. For people that have not taken it yet, that's a great place to start. It is often the best kind of starting ground to build your Azure certification path. Right on that Microsoft Learn page, you'll see that there are direct Learn channels that you can go through where Microsoft guides you and helps you develop that path and get the knowledge that you need to take that certification. When you're taking a certification, the thing to remember is that it doesn't necessarily matter if you pass the first time. Sometimes you fail, sometimes you pass. The thing to remember is that you're always learning. So if you fail, you look at the end score, you look at where you did good, where you did bad, and then you go back to that Learn page and you start to study again. We also did put together some references for you guys that you can take back. It's going to be a lot of what we talked about today. So looking at the Architecture Center, and we do have this in a PDF for you as well that you can take with. The Architecture Center link, the design principles that we talked about, common design patterns, the well-architected framework, the MS Learning Path that I was talking about with regard to the framework, the Azure well-architected framework review link, Azure Advisor and how to get started with this, the fundamentals certification, and then your MS Learn path. Within this path, you can take multiple different learning paths as well. So you could take your fundamentals, you could go down a data path if that's what you're interested in, but it's always important to keep learning. So with that said, I think we'll turn it over to questions and answers if anybody has anything, or Aman, if you have anything left to share before the end of the session.
Hey guys, we did have one question already come up in the chat, and that I think was related to the gatekeeper pattern. They're asking if it is something similar to a reverse proxy. Thanks, Aman. We'll hang around for another couple minutes if you all have.
Aman, do you want to take that one first?
So gatekeeper patterns are very generic in nature. It's how you interpret those. A gatekeeper pattern is just someone standing in between the application and the person who is trying to access the application. So something standing in between who reviews the request and then lets the request pass through. As Eric mentioned earlier, it sanitizes and reviews the request and then lets it pass through. So as Eric explained earlier, the gatekeeper could be a firewall, a gatekeeper could be application gateway with WAF on it that will look at the request and will ensure that the request is not malicious. There is no SQL injection being attempted through that particular request. Does it answer your question, Gary? Perfect.
Any additional questions? I also just dropped this in the chat, but just to let everyone know, yes, we do have a recording that will be shared out. Feel free to pass that on to your coworkers if you desire. In addition, by signing up for today's session, you are registered for the remaining sessions. So next week, we'll be talking about information security. Then we have DevOps on the 11th, what's new in Azure on the 18th, and optimization on the 25th. They should all be very similar, same time, same place. You'll get the reminders that week of each session, and you'll also receive the recordings for each of those if you are unable to attend. We do not have any virtual swag. I only have marketing materials for you, but you know what? That's a good idea. I think we'll do a giveaway at the final session. So be sure to at least hop on for that one. Thanks, Dan. Hey, thanks everyone. For joining. I will also share mine and Aman, if that's okay with you, your email address. So if you happen to have any questions that come up after the fact, you can shoot them our way and we'll do our best to answer those for you.
Thanks, everyone.
Great. Well, I'll be here for another minute or two, but I hope that everyone has a wonderful weekend, and I hope that we'll see you for the rest of our 4 sessions in the coming weeks. Thanks, everyone. Thank you, Aman and Eric.
Thanks for your time.